Another way to categorize or classify matter is by looking at the composition. So here the two broad categories are pure substance or mixture. In a pure substance, there's only one type of atom or molecule. If you look at the individual particles, they are all the same. That's a pure substance. They could be all atoms, they could be all molecules. Here's an example. Pure water is composed only of water molecules. All the particles are the same. There's one kind of particle. It's a pure substance. In a mixture, you have two or more different types of atoms or molecules. The particles are going to be different. There's at least two types. Could be 3 or 5 million different types. The proportions can be varied in a mixture. So if you think about maybe putting salt, a little bit of, a pinch of salt into a cup of water, that's a mixture. You've got salt particles and you've got water particles. You could also put half a cup of salt into the water. You can vary the composition. So here's a flow chart. Some people like these, some people hate them. But it's here regardless. So matter. We can divide this into pure substances or mixtures. Mixtures have more than one kind of particle. Pure substance, all the particles are the same. And then they can be further subdivided. Particles can be either elements or compounds. Mixtures can be either homogeneous or heterogeneous. So, elements are pure substances, one category of a pure substance. In an element, all of the particles are the same kind of atom. You can't break an element down into a simpler substance using a normal chemical transformation. So water is not an element. If you put a 9-volt battery into water, you'll see bubbles form, and the electric current is changing the water into hydrogen gas and oxygen gas. That's a chemical transformation into simpler substances. The oxygen is an element. The hydrogen is an element. They are the simplest substance. The known elements are listed in your textbook. Depending on your version, it may be in the front or the back cover. We have a periodic table here leaning against the wall. That shows all of the known elements. So, if you're looking to determine if calcium is an element or not. So, well, calcium is on the periodic table, it's an element. Brass, right? You think about aluminum and brass. Brass is a metal, right? Is brass an element? No. Brass is actually a mixture of several different elements. You look on the periodic table, you're not going to find brass. You might find Br, but that's not brass, that's bromine. So one way to identify an element is to find it on the periodic table. That's where the alphabetical list might be helpful. If you can't find it in that list, it's not an element. The other type of pure substance is a compound. So a compound contains 2 or more elements. That's what makes it not an element, because it can be broken down into those individual elements. It may be hard to do, but it can be done. So it's composed of 2 or more elements, and what makes it different than a mixture is they have fixed, definite proportions. So in water, there are always 2 hydrogen atoms for every 1 oxygen atom. Always. It's always the same. That's what makes it a compound rather than a mixture. Compounds are much more common in nature than pure elements. Pure elements are hard to find, just hanging out by themselves. They are usually combined with other elements into compounds. Compounds can be decomposed into simpler substances. So a mixture is different substances, but they are not chemically bonded together. They're just jumbled, mixed together. So if you think about Lego bricks, if you take and you make little structures out of the Lego bricks, that's different than if you take those loose pieces and just jumble them together. A compound has the atoms bonded together, and we'll talk a lot more about how they do that. A mixture can be separated, and the proportions can vary. You could have a little bit of salt in the water, you could have a lot of salt in the water. think I've got a picture. So here is, here's a mixture. So compounds are not mixtures. A mixture is something like this. The ocean water. There are water molecules and there are salt particles. And the composition here, the ratio of green balls to these little Mickey Mouse water molecules can be different. You get a freshwater river running into the ocean, and as it goes through the delta, the water becomes more and more salty until it gets out to the ocean where the salt content is the highest. The salt content can vary. It's a mixture. These salt particles are not chemically bonded to the water. They're just swimming around with each other. The air that we're breathing is a mixture. There are oxygen molecules and there are nitrogen molecules. They are not chemically bonded together. You could have a little bit of oxygen or you could have more oxygen. It's a mixture. We can classify mixtures by how uniformly they mix. We use a lot of prefixes and suffixes in science. And so the prefix homo and the prefix hetero. Homo means the same. Homogeneous is a mixture that looks the same throughout. It's uniform. A heterogeneous mixture, hetero means different, it has at least two distinct phases. It's non-uniform. So think of a food that looks homogeneous. Maybe a soup. Cream of something? How about cream of tomato soup? It's got that kind of red-pink color, and it's been pureed, it's been blended, right? And so it's all the same. So an example of a homogeneous mixture might be cream of tomato soup. Can you think of a soup that has pieces and chunks in it? Chicken noodle. So chicken noodle soup. There's broth, and there's chicken, and there's noodles, right? And sometimes there's other little things floating around in there too. Chicken noodle soup. You can see that there's different parts, and you could separate them. If you wanted to separate the broth from the chicken and the noodles, you could run it through a colander or a strainer, and you could fish out the solid parts and just separate the liquid. In a homogeneous mixture, it's more difficult to separate the components. Here, cream of tomato soup, it's been run through a blender to make all the particles tiny, and so they mix really well together. Any questions? So we should be, we're going to have to change that one. Well, let's do this. Because we did chicken noodle. We should be able to answer questions like this. Classify each type of matter as a pure substance or a mixture. If it's a pure substance, is it an element or a compound? If it's a mixture, is it homogeneous or heterogeneous? Now, some of these are going to be challenging at this point in your science education. The mercury in a thermometer, that's a pure substance. So that's a pure substance. Is it an element or a compound? Element. It's an element. Now, some of you might be saying, well, how am I supposed to know that? It might be kind of tough. Mercury is on the periodic table. It is an element. How about exhaled air? That's a mixture, right? Because what's in there? Yeah, there's CO2 because you breathe in oxygen and then you exhale CO2. There might be something that smells not so great depending on what you had for lunch, right? You know, I always get horrible breath after I eat hot dogs. So if I had a hot dog like I did last night, then it's like, terrible breath. Why? Well, there's smelly gases mixed in with the carbon dioxide, and there's probably nitrogen, and there's probably some water vapor. It's a mixture of things, right? Is it homogeneous or heterogeneous? Does it have chunks in it? Is it different layers? We're not talking about blowing chunks. That would be vomiting, right? We're just talking about breathing out. It's just a gas coming out, right? It's homogeneous. So this is a mixture, but it's homogeneous. It's the same throughout. Okay, chili with beans. Mixture or pure substance? Mixture. Is it homogeneous or heterogeneous? Heterogeneous. Because there's the chili part, the soupy stuff, and hopefully there's some meat in there, and then there's the beans, right? You can see there's different parts. So that's a heterogeneous mixture. How about sugar?
Pure.
It is a pure substance. Is it an element or a compound? It's a compound. Sugar is a compound composed of carbon, hydrogen, and oxygen. Which I don't expect you to know that, but sugar is a compound. Any questions? So this is just a summary. Matter can be a pure substance or a mixture. Pure substances are broken into elements or compounds, and mixtures are either homogeneous or heterogeneous. Mixtures could be two different elements mixed together, or it could be two different compounds, or it could be an element in a compound, or it could be 5 elements and 2 compounds, any combination.